Suppose you want to use radiation pressure from the sun to help propel 5,000 kilogram spacecraft around the solar system. So if we assume that the sun intensity, or S average, is 1000 watts per meter squared, and the sail is a 1 kilometer by 1 kilometer of the spacecraft. So the area is 1 kilometer times 1 kilometer, and it is highly reflective. We want to find out how much force would be applied on this highly reflective 1 kilometer by 1 kilometer sail. So we want to find out the force. Question mark. That's the A. Second, so we want to find out how much would it increase the speed in 1 year. So we want to find out like a delta V in 1 year. So this is given to us. And finally, we want to find out how far it will go. It will travel in 1 year if it starts from rest. So let's say we want to find out the distance it will travel in time equals 1 year. And when we start with when the sail starts from rest. So rest is 0 meters per second. Well, let's start from part A, where what do we know about the reflective surfaces and radiation pressure? We know that radiation pressure equals 2 times, because it's highly reflective, S average over the C. And the force would be approximately equal pressure times the area. And all we need to do, find what is the pressure in numerical value. Let's go ahead and plug in the numbers. 2 times 1000 watts per meter squared divided by 3.00 times 10 to the 8 meters per second. This will give us a value 6 times 10 to the negative 6 newtons per meter square. Now, if I plug this one into here, then I will get force equals 6 times 10 to the negative 6 newtons per meter squared. Let me just go to the side a little bit. Times, well, 1 kilometer is 10 to the 3 meters, and times again 1 kilometer, that will make it 10 to the 6 meters squared as an area, and we will end up getting this equals 6 newtons. So for the second part, where we want to find the change in speed, okay, so change in speed. First, let's recall from kinematics. We know that find the velocity at any moment equals the initial velocity plus at. So we know that the time is given to us. It's 1 year. Now we need to find the acceleration, and so delta V would equal V minus V initial, which equals at. Now let's go ahead and find the acceleration here. For the acceleration, we're going to use Newton's second law, where F equals ma, and acceleration equals the force divided by the mass. We have 6 newtons divided by 5,000 kilograms that was given to us. and that will result in 1.2 times 10 to the negative 3 meters per second square. So if we plug that in to our expression, so this one into here, we will get changing the difference in velocity, the amount that the velocity has changed would be 1.2 times 10 to the negative 3 meters per second squared, and times that was a 1 year. Now we have to convert it into seconds, right? So 1 year is a 365 days, and 1 day is a 24 hours. 1 hour is 3,600 seconds. So punch this into calculator, we get approximately equals 4 times 10 to the 4 meters per second, or that could be approximated at 150,000 kilometers per hour. Now let's go ahead and find how far our spacecraft will go if in 1 year, if it was propelled by the solar pressure, solar radiation pressure. So for the C part, we said that the aircraft start at rest, so V naught equals 0. So, and from kinematics, we know that the distance it will travel equals V naught t plus 1/2 at squared. So this is 0. And then we can plug it in just simply the numbers, 1/2. And then our acceleration that we found in a previous case, I will plug it in here. That would be 1.2 times 10 to the negative 3 meters per second square. Again, the same thing, it's 1 year, so 365 days, 24 hours per day, and 3,600 seconds. And then let's punch this into our calculator. We'll get 6 times 10 to the 11 meters. Well, this value is actually 6 times, actually 4 times, not 6 times, 4 times the Sun-Earth distance. Isn't this cool? We can move the aircraft without any providing any fuel to the aircraft. Just the fuel is right out there. Well, you can do more research on solar sails, and they are the scientists are trying to use this solar sail or light sail to propel spacecrafts in the solar system. So you might want to also follow the news, science news, to see where we are in this process. Yeah. Thanks for watching, and stay tuned for more examples.